So, hello everyone, welcome to Open AGI Forum. I'm Eric Wong from CSTM, and today, live from the GOSIM conference, GOSIM China 2024 in Beijing, we are honored to have Jim Blandy. He's programming Rust, so he's got plenty of stories to share and experience to share. So, welcome, Jim. Introduce yourself first.
Oh, introduce myself. Okay, let's see. I'm Jim Blandy. I've been doing free and open source software since 1990. I used to, out of college, I went to work for Richard Stallman. Then I worked on GDB. I was one of the maintainers of the GNU debugger. I was a maintainer of Emacs. I had a great time working on Subversion. I was one of the original designers of Subversion. That was a wonderful team of people, and they all went on to do amazing things. Subversion itself is dead now. I remember the time when I first tried Mercurial, and I realized, basically I just said, we were out-hacked. Mercurial is just so much better at everything that we wanted to do, in my opinion. So I switched away from Subversion. I never looked back. I have been, since 2008, I've been at Mozilla, and I've been working on various pieces of the company, various pieces of the browser since then. The JavaScript engine, the debugger, the dev tools, and now the GPU implementation.
Same.
And Jason Orendorf and I together, we decided to write, when Rust came out, I was friends with Graydon Hoare, the original designer of Rust. We were just personal friends at Red Hat. And he went to Mozilla first, and he invited me there. He suggested I apply. So I was talking with him regularly, and he mentioned that he was designing this new language, Rust. And I said, oh, wow, send me the manual. I want to try it out. And at that time, Rust was a very different language. Graydon himself is much more willing to compromise on performance to get sort of nice semantics, right? Whereas Rust is kind of a unforgiving systems programming language now. It's like we generate the best possible code. We are competitive with C++, right? That was not actually Graydon's original goal. But anyway, so by the time Rust 1.0 came out, we were very excited about it because the key thing that Graydon was most interested in was safety. And Rust had managed to find a way to be a systems programming language that was actually safe. I had not thought that was possible. I had thought that C and C++ had kind of reached the limit of what you could do, right? And like, how are you going to fix anything? And then Rust came out, and I was just astonished. And so I thought, oh, we have to write a book about this. But the key thing, the way that Rust gets its gains, right, is by being much more restrictive with pointers, right, in C and C++, right? That you actually have to give up something. You have to give up flexibility. You have to give up expressiveness in order to get the gains that Rust offers you. And I guess that was the part that I hadn't imagined was possible. I hadn't imagined that you could give up so much flexibility in the way you work with pointers and still have a language that's pretty nice to use. So once I saw that, I was like, we have to write a book about this.
So my first questions. Oh, actually, I have an additional question: is why we want to choose the topic today, WGPU?
Oh well,
yeah. So I want to know the story behind you how to learn the WGPU.
Well, it's kind of silly. I really wanted to try moving into a different kind of program. I had been working in the SpiderMonkey team at Mozilla. That's their JavaScript engine. And Jason Orendorf and I, my co-author with Programming Rust, he and I implemented the debugging API for the JavaScript engine that's in Firefox now. So that's what's using the dev tools, the developer tools. And then I was on the developer tools team for a while, but I really wanted to try something different. And so I asked if I could transfer to the graphics team. And I just let them put me wherever they wanted. So I ended up working with Dmitry Malshau, who is he's one of the original founders of the WebGPU effort, and he's the main originator of WGPU and of Naga, both of those components. And so I was his assistant, then he got hired away by some other company, and they said, "Well, what are we going to do with our WebGPU implementation? Jim, do you want?" So I became the tech lead, even though I actually don't have much graphics background. But one of the really funny things about graphics is there's just an enormous amount of detail, right? Whenever you try to learn graphics programming, you're like, well, wait a second, why is there a uniform buffer and a storage buffer? Why are those two different things? They're both just blocks of bytes. Why is there this distinction? And there's just so many questions that come up like this, and so I wanted to understand for myself, the rationale for all these design choices that are coming out in WebGPU, but they're really just reflections of things that are in Vulkan or Direct3D or Metal, right? And so I managed to, over time, put together an idea, a general understanding of what it is that's motivating a lot of this stuff. And really, like I said in my talk today, almost all of it comes down to memory pressure. That basically memory is slow. It's dog slow. And the only thing that you can do about that is the only thing that you can do to fix that is to make multiple copies, right? If you've got 10 memories, well, then you've got 10 times as much bandwidth, right? Or maybe you want to put smaller memories that are closer to the computation units, right? And so each one of those will have its own bandwidth independent of the rest, right? So almost all of what's going on in graphics programming is in some way or another related to dealing with memory bandwidth, just dealing with the restrictions of memory bandwidth. And so that it's sort of like this North Star that you can use to understand a lot of what's going on in GPUs. And so when Sid invited me to give the talk on WGPU at GOSIM, I thought, oh, this is a chance for me to share what I've learned, in the process of coming up to speed as a graphics programmer, because I wasn't much of a graphics programmer at the time when I started. It's a chance for me to share what I learned in that process with other people, because it is kind of a cool story. There is really a reason for the complexity in these APIs. So.
Yeah, I know why they put you in the next generation media.
I don't feel like it. When I'm talking about things that happened in 2014, 2015, is that the next generation? The next generation is something we don't know, right? I don't know what's going to happen. It's funny. So what's happening right now is there's an enormous interest. There's actually this big burst of interest in WebGPU within Mozilla, but also within Mozilla's partners. And the same thing is happening at Google. We're on the standards committee with Google and Apple and Microsoft, and so we talk a lot about what's going on. And there's just this enormous interest in WebGPU that's mostly being driven by machine learning and AI, right? Because you definitely do not want to run your models on the CPU. You must run them on the GPU. But one of the crucial operations in a lot of the models that people are running these days is matrix multiplication. And it turns out that the architecture of modern GPUs, like the one that I showed in the talk, it's not very good at matrix multiplication because there's a bunch of data flow that needs to happen there that just, there aren't wires for it in that design. And so the next generation of GPUs, what I think they're going to do is they're just going to be rearranging themselves to be better at matrix multiplication. And then the other thing, of course, is that they're going to be better at using very low precision stuff. AI doesn't need 32-bit floats. They're doing a lot of stuff. They often use 16-bit floats now, but you don't even need that. There's an 8-bit float format, which people have heard of, right? And so the GPUs are going to start supporting all these formats locally. And the fun thing that I heard of was that there's actually a 4-bit numeric format you can't call it floating point because you can't fit a mantissa and an exponent in 4 bits. What's really happening is they've said, look, here's the distribution of numbers that we care about representing. Let's pick 16 points in that distribution and assign them numbers, right? Assign them bit patterns, right? And then have design some circuits that can do math on it. And so I think the only thing that I can think of as next generation would be better support for these big matrix operations and better support for tiny numeric formats, very lossy, coarse numeric formats. That doesn't seem really revolutionary though, right? Those seem very evolutionary, right? You can certainly imagine adding a mode to your arithmetic unit that processes these smaller numeric formats, right? You can certainly imagine just adding the paths that you need in your GPUs to get the matrix multiplications there. So honestly, I mean, as far as what the next generation is, I honestly don't know. I suppose I shouldn't say that in an interview, but I really don't know.
Want to write a next generation graphic programming into the next third version.
In the next version of the book?
Yeah.
The thing, I don't think we will. We will. Because one of the things about a book is when you're explaining something, you're using the example to teach the language. And you have to make sure that the example itself is not so distracting that people can't even understand what the example is doing, let alone figure out what you're trying to do with Rust, right? And the thing about programming, graphics programming, is that it's so full of weird details and surprising details, and I think it would just be very hard to get something in there that people could really understand that wouldn't be a distraction from the language itself. Choosing good examples is one of the hardest parts of writing the book. And I think in some cases we manage to find really good examples. In other cases, it's not so much fun. But it happens constantly. We are actually working on a 3rd edition of the book now. O'Reilly wants to have a 3rd edition out in 2025. And so we are revising the book for the 2025 edition of Rust. And our conversations always, we look at some chapter and we're like, that example sucks, right? That's so boring. We've got to do something better than that. And then we're like, well, this example fits on a half a page. It touches that point, it touches this point, it makes that point, it avoids this distraction. Maybe we have to keep it. So, it's finding examples is very hard, and at the moment it looks to me like the graphics stuff is not like in that sweet spot of being both good didactically, right? Being good for teaching people the language Rust and also being sort of being interesting. Yeah. I would love to combine them, but the focus of the book is about teaching, right? Somebody once said, well, it's documentation. I said, it's not documentation, it's an explanation, right? The book is supposed to teach you, the book is supposed to prepare you for what you will find in the documentation, right? It's supposed to give you the basic ideas, right? The outlines, the motivations, right? And so then when you go and look at the documentation, you're like, oh yes, of course, that makes sense. This is what I would have expected to see, right? And so basically, we always have to be focused on the teaching.
If the argument you just mentioned about this always happens, how can the 2nd edition comes up? How long did the 2nd edition take?
Well, 2nd edition. Well, some people seem to write really easily. Writing for me is always really miserable because I always think like, oh yeah, I understand this, I know all about this, and then you write something and it's garbage, right? Writing down what you think is a great way to find out that you don't actually understand it very well, right? And so it's very discouraging, and especially when somebody wants it on a deadline. It's like, wait a second, I just realized I don't actually understand this topic very well. I need to go and do some experimentation. I need to write some fun programs and just mess with things a little bit before I even understand it well enough to write about it. So it's actually pretty stressful. The 2nd edition took a long time. The third edition, we've actually got all three authors back on board. The first edition was me and Jason. The second edition was just me and Nora. Third edition, it's all three of us. And so hopefully we will be able to, to help each other out and inspire each other and encourage each other. And
Very cool argument.
Yeah. And the other thing is that, just like the Rust 2025 edition isn't a big revision to the language, 2021 edition had async, right? That's a huge change to the language, right? And there was actually a lot of other stuff. There was the non-lexical lifetimes. The second edition was a big change. The third edition is not. It's a much more incremental thing. So I think we're going to be able to do better with that.
So as a developer who has dedicated their entire career to the free software movement, so what do you consider to be the movement's greatest achievements and the challenges over the years?
Well, so I'm more optimistic. I have friends who feel like the free software movement is dead, right? And I can't understand that at all. I don't think that at all. I think the free software movement's biggest accomplishment is that developers just assume that the tools that they work with should be free, right? Everybody's just like, well, of course I use this and that and the other free thing, and that wasn't a standard expectation back when we started, right? Back when we started, the assumption was that software is a business, and when you use some software, you pay somebody for it, right? And that person, in order to make sure that other people will pay for it, you can't make a copy of it, right? And of course, the free is freedom, not price, but in order to be able to charge a price, you have to restrict people's freedom. So that's what I'm saying, is that people assumed that they were going to have to go along with the whole proprietary software model. And people don't think that anymore, right? You've got all of GitHub, which is basically dedicated to promoting development of open source software, right? They make all of their tools, all their stuff available for open source projects, right? GitHub itself isn't open source, but I think that it's obvious that it is a very supportive home for a lot of really interesting work. So I think that change in the way developers think about what they ought to have is really the biggest thing. That people nowadays think that they ought to have access to the source. People think that they ought to have stuff that they can use royalty free. People think that they ought to be able to turn in bugs and participate in the development, and if things aren't going the way they want, they ought to be able to fork it, right? And those are they're just sort of built into the industry now, and it's going to be very, we can't really get rid of it. The people who are pessimistic about open source, I think they look at stuff like, say, the Linux kernel. Certainly the Linux kernel is an amazing triumph of open source, and the more people adopt it, the more uses it gets put to, the firmer that grip gets. But it is so important to, say, Google. It's actually, Linux is really important to Microsoft. It turns out that the reason that Microsoft became so much more friendly to open source over the last 10 years, I think I have that time period right, was basically they realized that they were making more money on Azure than they were on Windows. I think that's still true. And the people who were using Azure, they wanted to run Linux on it. And so Microsoft realized what side its bread was buttered on. And so they realized, well, I guess we better be friendly to Linux. And so you have all these big, huge companies, these 600-pound gorillas that have a big stake in the kernel, and it's very difficult to, I think it's very difficult to always keep to your principles when that's the situation. For example, there have been cases where people are shipping the Linux kernel and they're not providing sources. And then that's, it's a clear violation of the GPL, and it's very difficult to get that enforced. So, my friends who are pessimistic, they have reasons, right? They're not being unreasonable. But to me, just the fact that everybody assumes that developer tools ought to be open source now, and that people publish so much stuff as open source, I think is really it's really wonderful.
As a former maintainer of GNU Emacs, so how do you view the role of classic software like Emacs in modern programming environments?
I think Emacs. So here's the thing. Okay, when I started using Emacs, that was GNU Emacs. That was 1986, right? That was a long time ago, right? The cool thing about Emacs is that every time you started it up, it did something fantastic and useful that you weren't expecting, right? Like, this really sounds silly, but like the fact that you could just hit tab and it would indent the line for you properly, right? Nowadays, everybody just takes that for granted, right? It's not an exciting feature, but back then, it wasn't something that you could assume, right? And so the fact that Emacs did that was great. But then you'd open up a Perl script, right? A Perl, like I've never heard of Perl before, right? And it already knew all about Perl. It knew how to indent Perl. It knew how to like do all this stuff for Perl, right? And so Emacs was this fantastic community to be in because there was so much effort going into, and so whatever you were doing, Emacs was already there making it easy for you, right? So that was what it was. Where is that energy now? I think it's pretty clear that that energy is now on Visual Studio Code, right? The Visual Studio Code is where you find weird plugins. It's like, oh wait, that's exactly what I wanted, right? And so I think that the Visual Studio Code really is the successor, right? It's the heir to the spirit of Emacs. I had a friend who wrote something for Visual Studio Code where if you typed really fast, then it would set your words on fire on the screen and it would play like, guitar music. And so, that's dumb, but it's really funny, right? Yeah. And he actually forgot he had it on, and one time he was typing really fast and it said it set on fire and started playing guitar music, right? Like that is what Emacs was back in its time. And so I think it's really great that kind of energy has a new home. I still use Emacs because it's in my spinal cord. I have just reflexes now, and I just can't be comfortable anywhere else. And so I still use Emacs. And there's things like Magit, the Git front end, which is just amazing, and org mode, and the language server support is quite good. So I'm actually pleasantly surprised that Emacs is still keeping up, but I mean I do consider it kind of a dinosaur, and I consider myself a dinosaur, and I will use Emacs till the day I die.
I remember in your introduction you mentioned that open source practice are the best way to develop programmers' tools.
Yeah.
So do you think this model can be successful applied to other fields like the music or map making you mentioned?
Yeah, so that's something, I said that a long time ago, and I was thinking about taking off because I don't think, well, so first of all, there is OpenStreetMaps, right? OpenStreetMaps is a really fantastic, that's I think one that worked out, right? Like when I go hiking, I live in Oregon, and Oregon is just a wonderful place for hiking. There's just beautiful mountains, and OpenStreetMaps is the best way to get hiking, to get hiking trails, because people fix them. People, when something isn't right, somebody goes and fixes it up. So I think OpenStreetMaps maybe is an example of something where it did work. Obviously, with music, it didn't happen. I think music, what people want from music is they want a connection to the creator. They want to feel like they're like they understand something important about how the creator feels, and so I think it really is much more of a connection to an individual. And I think open source, you do give up the individuality, right? It is a collaborative, collective effort. It's like Wikipedia. Nobody says, I'm the author of this Wikipedia article. Nobody says that because nobody isn't the author of a Wikipedia article. Everybody's the author of a Wikipedia article, right? So, and I think open source is kind of like that you can say, oh, I founded this project, but it's not going to be your code. like a lot of Dimitri's code is gone from WGPU. There's all kinds of stuff that just in the process of making things, really bringing it up to standard, things that we found just had to be reworked. And that's the nature of open source. And so I think that things where the identity of the creator is important, I think it probably can't work for that. But with software, people just want it to work.
Yeah, in your book you compare Rust to C and C++. Yeah. So can you elaborate on how Rust has changed your perspective on systems programming languages?
Well, so I thought, before Rust came out, this is similar to what I said before. Before Rust came out, I felt like there really wasn't any opportunity for much improvement in systems programming, because when you think about what a systems programmer needs control over the resources of the machine. A systems programmer needs to be able to predict what code is going to be generated roughly, right? They need to know how data is going to be represented in memory roughly, right? And that, because that's their bread and butter. They need that kind of control. And if you start from that premise, it's pretty easy to, follow the chain of logic that leads to a design like C, right? And then you say, well, okay, but C is pretty hard to use. How can we make it? How can we actually, make it better for programming in the large? How can we support generics? And then C++, the design of C++ becomes really obvious. So I really didn't think that there was any opportunity. And I think what Rust showed me was that we actually have a lot of choices when we design something. That when you say, I need to write this, you actually have 10, 15 different possible designs. There's always so many different ways to write something, right? And what Rust does is it steers people towards the safe ones, right? You've got this whole collection of possible designs you could go in. Some of them are going to be wildly unsafe, and then one of them is actually Rust, right? It's actually something that you could use and something that you could write in Rust. And so the way that Rust is actually able to be usable, right? I mean, it's easy to write a safe language, right? Just everything is strings, right? There are programming languages where the only data type is a string, and all the operations are string operations. And when you do arithmetic, it's actually, numbers as strings, right? Those are safe languages.
Yes.
Nobody wants to use them for systems programming, right? They're not acceptable. Or you could take a systems programming language and say, look, you could say it's, I'm trying to make this up on the spot, that all you've got is an array and the only thing that you can do is index into it, right? Well, that's safe. Nobody wants to use it, right? And so it's not a question of, it's not hard to make a safe language. What's hard is making a safe language that people are willing to use, right? And that's what really surprised me about Rust, that they had identified this kind of, if you're not familiar with it, it's kind of an odd subset, right? That is actually pretty much what you need. There's a friend of mine who's an extremely accomplished programmer. He's one of the original authors of GNU grep. When GNU grep came out, everybody in the whole Unix world installed it because it was so much faster than everybody else's greps. So this guy is, and then he went on to do all kinds of amazing things. Anyway, so I talked with him about Rust when Rust first came out, and he said, yeah, I don't plan to use it because I do a lot of stuff where I have graphs, and I build my graphs with pointers, and Rust will not let me have cycles, and I can't use a language that doesn't let me have cyclic pointers, right? And I mean, Rust does, but like you have to use interior immutability, and then the cycle collection may not work, you might get leaks. It's not Rust's strength. And so I thought that was, kind of a legitimate reason, right? Because he's saying, look, here's this thing that we've been doing for 40 years in our programming languages. We've been building graphs out of pointers, and then here's Rust saying, like, sorry, you can't have any cycles anymore. He didn't want to go along with it. I think that's a perfectly fine thing to say. But, well, right now I'm working on WGPU. Well, part of WGPU is Naga. Naga translates shaders from, Wixel or GLSL or SpearV into other languages, right? That's a compiler. A compiler is just something that translates things from one language into another, right? Translates programs from one language into another, right? So I work on a compiler all the time, and you would think that I would be running into this graph restriction, this cyclic graph restriction that my friend was a deal breaker for my friend. We just have other ways of handling it. We have something called handles, actually. We have arenas, and we have handles that are indexes into arenas, and it's not perfect, but it's good enough, right? And I guess that's one of the things that is a surprise to me, is that you can actually have great perf in ways that do fit into the Rust development model just fine. So I was really surprised that Rust was able to sort of find this restricted view of things that was still actually usable. Although, so the restrictions that I'm talking about are the fact that you can't combine sharing and mutability in Rust, right? If you have data that multiple people are looking at, if it's shared, right, you have the shared references, right? If you have that, then the data is immutable, right? You can't have, if you have a mutable reference to something, then nobody else can see it. All access to that object has to be derived from the mutable reference, right? And so that's, I don't know, that's kind of restrictive, right? So my co-author Jason Norendorf he made a hobby of taking random C programs, not important ones, not useful ones, just taking random C programs and rewriting them in Rust, just for fun, right? And after he'd been doing this for a while, he said, usually the conversions go fine. You're just going along and like everything works out fine. But occasionally you get something in the C code that you just can't quite fit into Rust, and it's like, boy, I just can't see a way to translate this. And he says, I have learned that every time that happens, there's a bug in the C. Right?
Really?
And what he said literally was, when the borrow checker smells smoke, there's fire. Right?
Good saying.
And so that's really
that's good saying.
that's it's really surprising, because like you sort of assume, like, the premise of C, right, is like, well, I know what I'm doing, right? It's tough, but if you're going to be a professional programmer, that's just what you got to know, right? And that's the attitude that they have there. But we know that they screw up a lot, and this was Jason saying, every single time there's something that doesn't fit well into Rust, there was a bug. So maybe that extra flexibility isn't so great after all, right? So yeah, I think that was pretty interesting. It's like you may think that you have extra freedom, but I think we need to think carefully about how well we're really pulling it off, and how often we're actually managing to succeed in writing a correct C++ program. I think they're much rarer than people think.
I think because of the time problem, so at the end, as an experienced programmer and project maintainer, what advice do you have to the new generation of programmers? So in your view, what are the key skills or qualities needed to become an excellent programmer?
I don't feel like an excellent programmer very often. I guess maybe what I could say is the most important thing that you can do as a maintainer is to sympathize with the reader. right? Somebody else is going to be coming and reading this code, and you have to really think about what it's going to be like for them. I know some people who are very talented and capable, but when they go after a problem, it looks to me like they try to use every tool that they know, right? Their solution, it's got macros, it's got traits in there, it's got, I mean, none of these things are bad, right? I'm not saying that macros are bad, but you know, they'll do const generics, it's like they feel like they have to throw the kitchen sink at the problem, right? You know, sometimes it's okay to just have a function that takes an array, right? Sometimes it's okay to just do something at runtime, pay a little runtime cost, have something be an enum, right? You don't. Not everything has to be, you know, generic to the ends of the earth, right? Think about what process the poor reader is going to have to go through to understand what you've written. And remember that what's easiest for your readers is what they expect to see, right? It should be simple, it should be based almost entirely in the parts of the language that everybody knows and uses every day. It should be sort of proportionate to the problem. Don't use more of the language than you have to. You know, write documentation for it. All of these things are ways of showing courtesy to the reader. I feel like I'm calling somebody. I feel like I'm accusing somebody of not caring about readers. I don't think that's really true. I think that everybody thinks that what they're writing is beautiful code. I think almost always people think that what they're writing is perfectly fine. And so maybe what's called for is to, when you yourself are feeling confused, when you yourself are frustrated, when you yourself walk into some code and say, this is ridiculous, right? Note what made you feel that way. Pay attention to what confused you. Pay attention to what you felt wasted your time, and make sure you are not doing that to other people. Yeah, I think that's my biggest advice as a maintainer. There's a lot of stuff. I think maybe my weak point as a maintainer is the stuff about social interactions. Like, for example, it's really important to do fast reviews, right? When somebody posts something, when somebody makes a contribution to your project, then they have to wait and they like forget what they were doing because you didn't review their stuff fast. That's bad, right? When people aren't triaging the issues, that's bad. You know, but these are things where I'm a very slow reviewer, and I tend to sort of get focused on what I'm working on. And fortunately, I have other people on my team who just love that stuff, and who who dive in and take care of those things for me. I think that running a successful project probably rests on having a bunch of different people who have a bunch of different sort of things that they are drawn to, and like fitting those pieces together. So maybe I am working on the documentation. Like I actually write a lot of documentation for WGPU. I just dot comments everywhere. And then there's other people who are really great at taking care of the reviews, right? And there's other people who are really responsive on chat, right? When somebody has a question, right? All of those things are really important. And forcing people where it's awkward for them to do those things is probably not a good idea. But if you can have all these different people who have different attitudes and stitch that together to cover all the things you need to cover all the bases, then I think that's probably the real secret.
So thank you, Jim, for the insightful discussion, and thanks to all the developers watching. So that's all for today's podcast. So see you next time.